Okay, so let's do 2 more examples using our mole conversion chart. If we take a look at 2 more examples here, we'll do 8 and 9. First, again, we want to figure out what we're starting with and what we want to end with. So we have a bottle of potassium permanganate, which is right here, contains 66.38 grams of the compound. How many moles does it contain? Well, we're starting right here in grams, so that's what we're going to start with. 66.38 grams of potassium permanganate. We'll do our times in a line, and we want to get to moles. So let's look at our chart again. Grams is down here in mass. Moles is in the center. So I want to follow the arrow using this conversion factor. Now, some of the problems that we've done so far have been multi-step problems. However, after we go to this one conversion factor, we've made it to moles, which is where we want to end up. So this is going to end up being a one-step problem. So we'll go from mass to moles, again using 1 mole over the molar mass. Remember, molar mass comes from the periodic table. So we've got 1 mole up top of the potassium permanganate, and we have the molar mass on the bottom. And when I add potassium, manganese, and 4 oxygens, I get 158.03 grams. If we take a look at our math, our grams, because they're on opposite sides of the division bar, will cancel. We'll be left with moles of potassium permanganate, which is what we want. So I'll do 66.38 times 1 divided by 158.03, and we get 0.42 moles of potassium permanganate. Box that off as our answer. So let's take a look at number 9. Here we're determining the number of atoms from the number of grams. So again, we start with what we're given. If we're going from grams to atoms, let's see how many steps we'll need. We're starting down here in grams, and we have to make it to atoms. Can we go right from grams to atoms? There's no arrows here, so that's not possible. We can, however, follow the arrows 1, 2 to get from grams to particles. So we'll have to go up to moles and then back down to particles using 1 over the molar mass, and then 6.02 times 10 to the 23rd over 1 mole. So we'll do our times in a line. We've got 1 mole over the molar mass of selenium, that is. And as I look that up on the periodic table, selenium is 78.96 grams. If we did the math, we'd be left with moles, but we want to get down to atoms, so we've got to do that second step. Again, mass to moles, we use the molar mass. Now moles back down to particles, we'll use this guy here. One mole of selenium for every 6.02 times 10 to the 23rd atoms of selenium. Now we'll plug this in our calculator. All right. So we're going to do the 0.58. We'll multiply it by the 1. Divide that by the 78.96. We're going to multiply it by our 6.02 times 10 to the 23rd. Remember to use that EE button. If you're using a graphing calculator, it'll be second comma. If you're using your iPhone, there's an EE button if you switch the phone over to landscape view. We divide that by 1. Oh, something messed up there. Let's try again. 0.58 divided by 78.96 times the 6.02 EE23, and we get 4.42 times 10 to the 21st. That's what that little 21 up there stands for. So we'll write that here as 4.42 times 10 to the 21st atoms of selenium. And we'll put a box around that for our answer. Alright. If you have any other questions, this is the second of 2 videos, so you can watch the first video or shoot me a message on BCPS1 and I should be able to answer it for you.